Hey, this KP the Math G up here. This is on the eve of Thanksgiving Day. How about that? Well, there's going to be Turkey Day for a lot of us tomorrow, including ourselves. We're going to have both turkey and ham. We're going to have a lot of good food, and I'm going to eat a little bit more. But I'm going to try not to eat too much. So anyway. KP the Math G, this is the first derivative, and this first derivative has to do with a function that's increasing or decreasing. In this particular case, later on we can look at the first derivative. We've already seen that derivative before, being the slope of the tangent line, and we've seen the first derivative when we looked at the mean value and Rolle's theorem and so on, and so many other things that we could look at. When we look at, for example, velocity, that is involved with the first derivative. So many applications with this first derivative. But we're going to look at increasing and decreasing functions. We have a function right here. We want to consider g at x as x cubed over 3 plus x squared over 2 minus 2x. On the closed interval negative 4 comma 3. I've already drawn the picture here. Here it is right here. I probably should have put it in a different color, but I've already graphed it for you. As a matter of fact, you see that from negative 4, which by the way on the calculator turns out to be negative 4 comma negative 5 1/3, somewhere down in here below here. I didn't have enough room, and I didn't have enough room to put 3 comma 10 over here on the other side. We have negative 3 comma negative 5 1/3, and from that, starting at negative 4 at x equals negative 4, we notice that the graph is constantly going uphill. This is nice to have a little picture of the graph already drawn for you. You see that from negative 4 up to 2, we have this graph is increasing. Okay, and so the graph is getting higher and higher and higher and higher until it finally reaches a plateau at x equals negative 2. The slope happens to be 0. Okay, and that is the horizontal slope. That is also the slope, one of the many slopes of the tangent line. This is one of the most important ones because at this point here, it's a turn. This is really a turning point, and we can turn downward now. So now from negative 2, in between negative 2 and 1, if you notice at 1 there is another slope here of 0. So between the two slopes of 0, okay, we should have probably said this is m sub 1 maybe, and this is probably m sub 2. But anyway, the two slopes are equal to 0. And in between, we notice that from negative 2 to 1, that this graph is decreasing, isn't it? So in other words, decreasing. In other words, at negative 2, we're at 3. I want to say 3 1/3. At 1, I think we're at 1 1/3. I think it is. I have to look at that. I'd have to look at the table again. But as we get further down, we're getting even past 0, 0 at 0, and then at negative at even between there, it's getting lower and lower and lower until the slope is finally 0. Okay. Negative 1. This is point negative. Positive 1. Negative 1 1/3 is what that is. But the slope is 0 there. And so what we have is little slopes little tangent slopes here along the way. All of them are leaning to the left, and that just simply means that this graph between -2 and 1 is constantly decreasing, whereas this one, the slopes are leaning to the right, aren't they? So if I had little b slope lines here, little b slope lines, these are leaning to the right. That means that the slope is positive. That means that if the slope is positive, then that means that the graph G in this case is increasing. If the slope is negative, the graph at G, between -2 and 1, is decreasing. And of course the slope turns positive again from 1 to 3. The graph again is increasing. Okay, so that's nice. We can see it from the picture already drawn before us. Well, what's so nice about calculus is that what if you didn't see this? Okay, I do want to show you the significance then of this first derivative. If I didn't have this drawn, could we determine from this closed interval -4 to 3 where first of all are the horizontal slopes? Okay, where then is G increasing and where is G decreasing? All right, and if we look at this, G is increasing from -4 to -2, also increasing from 1 to 3. It is also, but it's decreasing from -2 to 1. That's where those horizontal tangents are. Do you see that? Okay, so that's what we want to do. We want to see the significance behind it. So what we want to do is we want to take this derivative here. So I'm going to do that at this point. So G prime rather at x. Okay, G prime at x. Let's see what that is. That is 3 times x squared over 3. Remember, we reduced the exponent by 1. This is the power rule. We know that or should know that by now. Plus 2 times x to the first all over 2. All right, and then minus 2 here. So what we really have is that G prime at x, okay, is equal to x squared plus 2x. No, that's not 2x. Plus x minus 2. And I deliberately fixed this one up this way because some of these, if you have a quadratic, and that's what this is, you have a quadratic equation here. One thing about it that's so nice about this is you can factor this to see where the horizontal tangents are, and that's really where those critical numbers, where the turning points in this place are. Okay, so let's take a look at it. We're going to set this equal to 0. Now remember, why would we possibly set this equal to 0? This represents the slope of the tangent line. I want that slope equal to 0. I want every place where the slope is 0. Well, we already know from the picture that it's at -2 and at +1. Well, let's look. Okay, we're going to see that this is x plus minus, and I think I'm going to put my 1 here and 2 here. Alright, so right there. And of course, x plus 1, we're going to kind of work it out right here for the rest of the way. X plus 1 is 0, meaning that x is -1, and x minus 2 equals 0, meaning that x equals 2. See, all you got to do is when you move the plus to the other side, it's negative, You move the minus to the other side, it's plus. So that's where your critical numbers are. We already found that on this graph, but I'm saying, what if we did not have this graph to look at? Now I know, even without looking, that if I have a horizontal tangent line, it's going to be at x equals -1 and x equals 2. Okay, now let's flip this over. I want to actually do something here. I want to draw the graph and actually add it. I want to see how this works out. I may have to just keep erasing this little area here if I may. So let's put down that the critical numbers so far are at x equals, we already see it from the graph here, that we have the slope at x equals -1, the slope is 0, so m equals 0 at x equals -1 and at x equals 2. Okay, alright, so let's erase this. I want to try to keep everything on this side of the board, and I wish I had more room, but I just don't, guys and girls. Okay, so now I want to look at something else with this particular graph here. I want to erase this too. I need some room here. Okay, and I'm going to kind of erase everything that I can. Have a little more room to look at. Okay, alright. I want to try to draw the g prime, the derivative of g. I want to draw the graph of that on here. Now remember that g prime, let's see, okay, alright. We found that g prime, we've already done this just now, was, let's see, I want to say x squared plus x minus 2. And we want to actually set this equal to 0. That's where we want that horizontal tangent line. So we found, when we solved, we found that the horizontal tangents are at x equals -1 and at x equals 2. Okay. Let's take a look. Let's draw the graph now of this equation here. It's nice that it's a quadratic, and it's very nice that we already had the factors for this. But what I want to do is I'm going to leave it like this right here, and I want to draw the graph, and I want to use a different color. I'm hoping red will show. I really do hope it does. Let's see what happens here. Now if I draw the graph, now one way to draw this, now let's go ahead and say this is g prime, by the way. Okay, so one way to draw this is, if I can find out, since I know this is a quadratic, I know that this is going to be opened upward. I know you learned open upward, but in calculus we say concave up. It's curved upward because there's a understood positive number, it's 1, isn't it, in front of the lead coefficient. So we know that it's curved upward, but we want to find, in other words, this has a min, which we could get into, but we want to find out where that minimum is. Okay, so we know from algebra that x is equal to -b over 2a. And given that a is 1 and b is 1. I don't even need to worry about c. C is negative 2. I'm just looking at negative b over 2a. So negative 1, so negative x equals negative 1 over 2 times 1. Y'all see that? Alright, 2 times 1 is 2, so this is negative 1 over 2. So that is the x value of the vertex, which, by the way, happens to be the min, the absolute min for that matter. Okay, and I want to find the y value. All I got to do is just plug that in. So I want g prime at 1/2. All right, not g. This is g here. I want g prime. All right, so I'm plugging it in here. So let's see, negative 1/2 squared plus negative 1/2 minus 2, and I've already done the arithmetic. When you plug this in, you get this equal to, this is actually 1/4 minus 1/2 minus 2, and that equals, by the way, negative 2 and 1/4. So at negative 1/2, this is negative 2 and 1/4. Well, I'm going to put this point down here. I'm going to use this red to do this. So negative 2 and 1/4 is somewhere, it's at negative 1/2. So we're going to say negative 1/2 is somewhere between, should be right in the middle between 0 and negative 1. It better be, right? And then this is going to be at negative 2 and 1/4, right? Somewhere right there. Okay, that's my vertex. And I have found some other points as well. If I wanted to, I plugged in negative 2, and let me just look at my paper again. Notice that negative 2, I got 0, which I should get. And at 1, I got 0, which I should get. Why? Because this is negative. Remember, these are, this graph that we're about to draw is the graph of, this right here, when it crosses the x-axis, okay, that simply means that at these 2 points, that's where the slope is equal to 0. Because, by the way, this is, negative 2 comma 0, and this is 1 comma what? 0, isn't it? Okay, this is that point. That's where the slope is equal to 0. When it crosses the x-axis, that's the slope at 0. And it should be. We should have had that. Okay, so we could probably put up another couple of points. I did find some more. Well, I thought I did anyway. I want to say that at negative 3, I got 4. And so let's see, this is, let's see, 2.5 away. So, okay, right here at 2 then, I got 4 also. Somewhere right in here. Okay. I want to say that was it. Let me look at my calculator. I did put the graph. I've already graphed these. Let's see. At 2, that is 4. And at negative 3, I got 4. I don't know if you can see that up close. I'm going to bring that as closely as I may. If you notice, I highlighted negative 3 and I got 4 here. And if you look at 2 down here, I also got 4 for y sub 2. This is the graph of, this is the graph at y sub 2 here. I made this the y sub 2. I made this one y sub 1. Okay, so, something like this, y'all. Okay, so I'm going to do this. Cross down here. Cross here. Come down. And I didn't, sometimes we're not as particular about how far down this goes, we just know it does. Now this is the graph, remember, of G prime. Now let's think about this. We're about to bring our lesson to a close. What did we just graph? Everything above the x-axis means that G, not G prime, but G is increasing from, and we're looking at the interval from -4 to 3, but right now, right here, at this point here, all right, it's going to increase till it gets to this point right here. The slope here, M1, we'll call it M1, is equal to 0. So until we get to that point right here, as long as we are above the x-axis, then that means that this graph G is increasing on the interval from -4 to -2. So what we have here, let's put this up here, that G is increasing on the interval from -4 to -2. All right, it's increasing there. All right, we have another portion above the graph, but we'll look at that in just a moment. G is decreasing then, so if increasing is above the x-axis, decreasing is below the x-axis. So look, where is the graph of x? Where are the x values that are below, below the x-axis? So at -2, between -2 and, so this is M2. M2 is equal to 0 here. So we're going to go until I know this is decreasing here and increasing here, but what we're saying here, as long as this part is below the x-axis right here, this means that G itself is decreasing between -2 and 1. All this is below. We don't care what this looks like. We just know that this portion here in blue that I'm fixing to do in, this portion right here is below the x-axis. Again, we don't care what it looks like. It could be squiggly. We don't care. But it's below the x-axis, which means that that portion in blue is decreasing between -2 and 1. Now, I don't know. Somebody may get on to me for including -2 here and including 1 here. I do not know. Some people may do an open interval here like this, since -2 is already included here. Again, that's something that I just simply do not know. Do you do this, or do you do that? I don't know. Do you include the 1? I don't know. Do you include the 1 here in this one and then not include it on the next part? So anyway, I'm just going to leave it. And if your teacher or someone or professor tells you something different, then do it differently. Okay. All right, but it is decreasing on this interval here, isn't it? And also G is increasing from 1. All right, see, this is where the slope is 0, and above the x-axis all the way to 3. This does eventually go there, all the way to 3. All right, like that. So G is increasing between our, on the interval from -4 to -2, increasing from 1 to 3, decreasing at -2 to 1. So whether I drew this or not, and you can tell, I mean, my goodness, we can make these comparisons and tell immediately right here that this graph is increasing between -4 and -2. We made that observation at the beginning of the lesson. But here we see that the graph is above the x-axis between -4 and -2. we see that between -2 and 1 that the graph is decreasing. Well, look at the graph here of G prime. It is below the x-axis, which means that that portion is decreasing. Okay? And here again, at see where the slope is 0 here, this is where it starts to go back up again, right here. So all the way up, and we should probably, put a point somewhere, but we're just going to, well, anyway, we should go all the way to 3. We should go all the way to -4, and look at that and observe that. As a matter of fact, I can look this up real fast. I already have it there. Let's see. At -4, it goes up to 10. So at -4, it does go up to 10. And let me see here. I don't need this point anymore. And you don't have to be as meticulous as but you just have to understand the idea between how far down does this go. Well, okay, we were more careful about it, and that's really a good thing. But anyway, at -4, -4 comma 10 is somewhere up here. Okay, somewhere up here. And I believe at 3, 10, I think that's right. Let me see, 3. Let's see, 7.5. So at 3, and this the other one was, but at 3, this is, let's see. Okay, so up here, 7.5. Somewhere right here, so it should be over just a little bit. We can always scoop the 3 over and cheat it over a little bit, and there we go. 7 point, and let's see here, 6, 7.5, somewhere right in here. Okay, so there we go. I mean, this is not drawn to scale, is it? And I could probably even scoot it over even more. I don't know, not much more, but okay. If we want to be technical about this. This is 3, 7.5. Okay. All right. I do think that part is. Oh, I stand corrected. It is 10, and it should be because, well, okay. Okay, it is true. I need to scoot this back over. My bad. And I should know better than that, because this is symmetrical, about this, you remember there's a line of symmetry here. This should be it. Okay, so if this -4 is 10, and 3 should be 10 also. So yeah, 3, 10, wherever that is, up in here somewhere. Okay. All right, we're going to say it's up there somewhere. All right. So the basic idea is not so much where the points are, and I was very careful to do that correctly. Not so much where the points are in all this. You just need to know that if this portion and this portion here is above the x-axis, we know that G or X or W or whatever it is increasing on this interval and on this interval here. Okay, if it's below the x-axis, we don't know how far this went. We shouldn't care how far down it goes. We just know that this part is below the x-axis here, between the 2 turning points, or between the absolute max and the, well, not the absolute, but the local max and the local min here. Okay, between those 2 horizontal tangent lines. Okay, and so increasing, decreasing, increasing. Okay, increasing on this interval, decreasing on this interval, increasing on this interval here. Okay. And I got a little technical about this because I want to be right about it and all that. I want to do things the right way. But there it is. That's what we're talking about here. We already can see the graph, but we know, whether we know exactly what the graph looks like, we do know that what's increasing and what's decreasing by the first derivative. The first derivative is always going to show what's increasing and what's decreasing. The second derivative is going to show other things, such as a possible point